All right, guys, 5 o'clock. Let's get this done. Who's got questions? All right, so those of you that are in here with questions, I feel really, really stupid. Little Chris sent me some code to fix my chat, and as you can see right here, the chat is bigger now, where you can actually read it. But I feel really stupid because I didn't need to do all that. All I had to do was grab the corner of my chat dialog box and drag it down to make it bigger. Feel really, really stupid with that. But live and learn. It's now where you can actually read it a lot better. So, one person in here. All right. Anybody got questions? Or you one person have a question? Or this might be a short stream. Ugh. Good times. I'm gonna hit mute so y'all don't hear my... Got two people now. Anybody have any questions, or y'all gonna sit here and just watch me solve my Rubik's Cube?
Sign in.
What's up? Nobody cares. Let me finish solving this, and then I will do week 2, day 1, number 4 on practice 2. I remember right. It's algebra 2, right? Cool. All right, almost done. I'm like fairly OCD with the Rubik's Cubes. My wife and daughter will mix them up and leave them around the house. I just have to solve them. All right, so let's see. Week 2, day 1, number 4. Number 4. All right. Just a basic factoring question. Huh? Oh, I have 2 concurrent viewers on my side. Oh, yeah. Session, I got you. Yeah, I'm on session B. All right, so we've got x squared plus 15x. Wait, you want practice 1 or practice 2? Because there's 2 number 4s. There's 2 number 4s on this. That's weird. You want practice 1 or practice 2? Well, I'm going to do minus 16. So I'm going to work this one, and if it's the other one, oh yeah, 2. Perfect. So this problem right here. All right, so this is a problem where we're going to have to factor. So I'm going to do the AC method of factoring like I showed in the first tutorial. My A is a number right in front of this, which is a 1. This is my B. This is my C. So I'm going to do A times C, which is going to be 1 times a negative 16. This gives me a negative 16. Now, once we do the AC with this negative sign, that means that I'm going to have alternating signs. One's got to be positive, one's got to be negative. It can't be the same sign. Only when this is positive will they both be the same sign, like 2 positives or 2 negatives. So I'm going to list the factors of negative 16. So I've got plus or minus 1 and 16, plus or minus 2 and 8, plus or minus 4 and 4. and we're looking for something that's going to add up to positive 15. Well, because they're going to be different signs, I know that I can do 16 minus 1, and that's going to give me my 15. So I have the negative 1 right here and my positive 16. So I'm going to split this middle term up into these two terms with the x on it. So I'm going to have x squared, and always put your minus. If you have an option, put your minus first so you don't mess up your signs. Minus, and I'm just going to write this as an x, not 1x, but you can write it as a 1x, but minus x plus 16x minus 16 equals 0. All right, so now that we've got this middle term uncombined, we're going to group the first two, group the second two. Always make sure you have a plus sign in the middle. We're going to look at GCFs. X squared and x have what type of GCF? It has an x, so I'm going to factor that out, and that leaves me x minus 1. I'm going to come to this one, 16x minus 16. It's got a 16 in common, so I'm going to factor the 16 out, and that leaves me with x minus 1. This is perfect because these two have to be the same for it to be able to factor. So that's one of my factors. So one of my factors is the x minus 1, and my other factor are my GCFs right here. This becomes x plus 16, and those equals 0. All right, from here, we're going to do a thing called the zero product property. We're going to take each term and set them equal to 0, because if this equals 0, it doesn't matter what number this is. And if this equals 0, it doesn't matter what number this is, because 0 times any number is 0. So we're going to do x minus 1 equals 0, and x plus 16 equals 0. From here, we just solve. We're going to add 1 to both sides, and we got x equals 1. And we're going to subtract 16 from both sides, and we have x equals negative 16. So my answer, x is going to be the solution set of negative 16 and 1. Easy peasy lemon squeezy, just a basic factoring question. All right, fire away. What other questions? I don't know if y'all hear my dog. He's trying to decide, does he want to be in here or not. He keeps walking back and forth out of the room, and his nails are clickety-clack on my hardwood floor here. You're welcome. You're welcome. You're welcome. Hopefully that helps. I know factoring can be confusing. The only way you're going to get good at is doing it over and over and over again. At a certain point, you'll be able to do it a lot faster. So what else, guys? What else? What else? What else? Oda, what are you doing? What are you doing? Come here. Hey, come here. Come here. What else, guys? Any other questions? I know this week we didn't give you terribly hard stuff to do, not really knowing what's going on. So I don't really anticipate a lot of questions, but I'm here if you need me. So is Coda. Coda's here if you need him too. But he'll probably bark at you because he's mean. He's grumpy because he's 14. Ugh. What? 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 Why you look at me like that? Any other questions, buddies? What? You want to go get mama? Go get mama. Hey, stop that. Scratching your head. Stop itching. Give you a bath later. Oh.
Here, I'm right here. Oh wait, where's mine?
So I don't know if all y'all were on here, but I feel really stupid about the chat. If you can see now, the chat actually looks bigger on your screen. Little Chris sent me some code to actually help with that, and I'm using that code. But more importantly, what I realized is all I had to do is drag the click on the corner of my box and drag it and make it bigger. I felt really stupid. Guys, any of y'all have any other questions? It's just the three of us. I'm not going to sit here and just stare at the camera.
What's on your head?
He's scratching. Because he went outside and he had dirt on his paws, so he's got dirt all on his head now.
Not dirt.
Week 2, day 4, subtracting polynomials number 5. All right, let's look.
Come here. Couldn't stop it.
Week 2, day 4.
I'll spray your head.
All right. Adding, subtracting, number 5. All right, here we go. So number 5, we have x squared minus 33x. That was bad. Plus 7. Wow, I'm really old. I need to just get suck it up and get bifocals. Minus, they got parentheses around this. X squared minus 7x plus 41x minus 12. Okay. So on the surface, this looks crazy hard, but in reality, the first thing that I see when I look at this is I see I have like terms inside the parentheses here. So in math, we simplify to make our next step simpler, and combining like terms is a simplification step. So what I'm going to do is I'm actually going to simplify this by combining like terms before I even try to subtract these polynomials. And I'm going to deal with the parentheses up front. Because there is no sign here, it's assumed to be positive, these parentheses here are not necessary, so I can drop them. I'm going to get x squared minus 33x plus 7 minus. Now, because this is a negative, we do need this parenthesis. But I'm going to combine like terms. So I've got an x squared, and 41 minus 7 is what? 34? So plus 34x minus 12. Okay, so now that I've simplified this down, we need to make sure that we distribute this subtraction sign or this negative sign to every term in here. So we have to do the hippity-hoppity distributive property, which I stole from Miss Posey, of course, because I am not like that cutesy thing. I would just say just distribute and be done with it. So this turns into x squared minus 33x plus 7 minus x squared, because a negative times a positive x squared is a negative x squared. A negative times a positive 34x is minus 34x, and a negative times a negative 12 is a positive 12. And from here, we just simply combine like terms. I have x squared minus x squared. Well, those go away. That's 0. Negative 33x minus 34x should be negative 67x. And then 7 plus 12 gives me 19. And there's your solution. Not terribly bad. Whenever you see anything that's alike, combine it to make your life easier. That's just from working tons of problems. What else? What else? What else?
So was that?
Uh-huh. Yep. You know what's sad is I think only a couple people are going to use this, and this is really going to help them, and they're going to be ahead of everybody else.
What are you doing? Yeah,
Oh, what is he doing?
Stop. Stop. Fine.
He being defiant. Buddy. He just said, forget it. I'll go in a different room. You can't see me. Yeah. What else, guys? Hey, does the picture look better? I adjusted the color, the amount of brightness. That still looks good to me, though.
See, it looks good on there.
That might just be the iPad.
No, because the phone is generating.
It might be that what you're watching it live, maybe, I don't know. You're welcome. You're welcome. I know he wants to be YouTube famous.
Stop. We'll get it back.
Man, I tell you, adulting sucks. Right now, there's only 2 people on here. No. Nobody cares is in here. You think she left? He left? Whatever. I don't know. We can't assume anything. Oh, we'll give it like 4 or 5 minutes. If nobody asks a question, I'm just going to bounce and kill the stream. Nah. Required me to open up a calculus. Fine, you keep an eye on the chat, and I will open up a calculus book. Oh my goodness. Gilbert string. So I'm going to be working out of a MIT professor's calculus book. Which is typed in Law Tech.
Stop it.
All right. Well, what is that?
X equals x cubed plus 4.
Really? You just want the derivative of this? Well, that's a waste of time. That's 18x minus 9.
Yeah.
You want me to...
You want me to... I'll give you square.
Here, let me at least do this. So we're going to do the power rule. And the power rule basically says I want to take my exponent, multiply it by the number, and then I'm going to subtract 1 from my exponent. So my derivative f prime of x is 6 times 3, which is 18. And then 3 minus 1 is 2. Minus, well, 1 times negative 9 is 9. 1 minus 1 is 0. X is 0 power. Anything to the 0 power is 1. 0 times 4 is 0. 0 times anything is 0. And there's my derivative. Easy peasy. That's probably one of the easiest type of derivatives you can take. That's like a ridiculous easy derivative. Come on. No, I hate when I do that. Let me get out of this. Wait, there it is. Okay, figured it out. Okay, well, give me another one.
So 10 times the 5th. So 5 in front.
So the 5th root.
X cubed minus.
Inside or outside?
Outside. Plus. Yeah, getting yourself.
How many terms is it?
3, 4.
4 terms? You know, it's nothing more than a power rule. F of x equals, what is it? It's 10 to the 5th root of x to the what? All right.
Square root. Of x 8.
Cube root of x to the 8th.
And then
minus 3?
Yeah.
Oh, the minus 3 goes away. It's a constant. Yeah. Derivative of a constant 0. All right, so to find the derivative of this, not hard. This is where, all right, so if anybody watches this, and when I teach you exponent rules, and I say you need to know your exponent rules, I'm about to show you why. because I'm about to do exponent rules on this and make this ridiculous easy. Just as easy as the last derivative I showed. So I'm going to take, I'm going to use my exponent rules here, and I'm going to change this around. So this is actually to the 1/5 power. So I'm going to rewrite this as 10 x cubed to the 1/5 power minus x to the 7th to the 1/2 power plus 6 times x to the 8th to the 3rd power to the 1/3 power minus 3. Now when you have a power to a power, you multiply them. I now have 10 x to the 3/5 power minus x to the 7/2 power plus 6 times x to the 8/3 power minus 3. And now we just have the power rule derivative. We're going to pull this down and bring it down in front. So 10 times 5/3 is 6. And now 5/3 minus 1 would be a negative 1/2. No. No. 5/3 minus 5, negative 2/5. And let's see. So now we're going to do the same thing here. We're going to do minus 7/2 x. I'm going to subtract 1 out of this, so it's going to be 5/2. And then we're going to do multiply this out, so this becomes 16x. This becomes 3/3, so 5/3 power. And there's your derivative. Not bad. Not bad at all. Most of the time in calculus, just leave it like this. I mean, I could convert it back to exponents, and because this is actually a fraction, and do all types of other stuff with it. But more often not what you need it for. This is fine. Not hard. If you know your exponent rules, you've got to know your exponent rules. That's why people fail calculus. They fail calculus not because of calculus. They fail calculus because of algebra.
I agree. Nobody ever showed.
Nobody showed you that?
No. At all.
How in the world did they make you do this?
I don't remember, but I know we didn't.
Why don't you just ask me? This is like, you're just sitting there looking like, oh, you just did that in 4 lines.
I know. Like, no, because mine would have been like.
Well, like, all right, see, that's why my students get mad at me, because they'll take like a whole sheet of paper on a problem, and I'll solve it in like 3 lines, and they get mad.
Nobody's ever heard the.
Oh, that's all I ever do.
Perfect sense.
That's all I ever do. Because if I can get it to the power rule, I'm never going to mess that. I won't say never, but it's very unlikely I mess that derivative up.
The only one that was lower might have been the chain.
But the chain rule is just use substitution.
Ow. But when she brought it to us, when I asked you to help me and you showed me so I was like, oh.
So you just learned something?
Yeah, I was like, oh, yeah. I remember when I asked about if we can use substitution, they were like, oh, I guess that's not the way they want you to do it. But it works.
That's not hard. What else? Derivatives are fine. Integrals I'm so rusty at.
Oh.
No. Nah. That's not challenging. Do limits to infinity, or limits of infinity. I remember in calculus I struggled with those, and for the life of me I don't remember. I don't know why they're so easy. Limits, there's 2 different types, limits to and limits of. Doesn't matter. Sure, why not?
Okay.
Why not?
4 of x.
Should be a limit.
x. So this is 18 plus 9. Infinity. The b.
Huh.
Well, you're gonna find one at negative infinity.
One at positive infinity. Right. This is it?
Yeah.
Huh. I could just plug in infinity and I'm going to get 9. Well, I should get infinity because infinity plus that. What's happening on this with the graph, because it's an odd and then my leading coefficient, it's going to look something, the end behavior is doing this. So the limit as x approaches negative infinity this way is going to be negative infinity. And then b, the limit as x approaches infinity going this way.
The way their solution
looks nothing like mine. Am I right?
I mean, you're right. Your answer's right. But
you want me to explain what I did? Because I can do this in my head. This one's not hard.
Your answer's right, but did it like fraction?
Yeah.
Pulled out an x.
Yeah. I know what they did.
Cool. Okay.
I know what they did. So here's what I did. Limits to infinity.
Oh, wait.
Someone wants a question?
Yeah.
My bad. I'm sitting here having fun. Let me explain this real quick, and then I will do your problem, okay? Week 2, day 2. Okay, let me explain this. So, whenever you see limit as x approaches negative infinity or infinity, talk about end behavior of a graph.
Right.
So if you know your rules of end behavior, you know these answers. So because this is a polynomial and it's an odd polynomial, meaning my end behavior is going down and up, my leading coefficient, there's no reflection. So now, since I know as I'm going towards negative infinity, it's got to go to negative infinity. And as I'm going to infinity, it's got to go to infinity.
Makes sense.
I have no idea why I struggle with that in calculus. No idea. It's so easy.
As long as you know your
as long as you know your end behaviors. And this is end behavior. It was never expressly told to me that limits to infinity like this were end behavior. I didn't figure that out until I was in Dr. Diesel's class with like a year left on my degree. And then as soon as I realized that working at the math lab, I was like, kidding me? You kidding me?
So week 2, day 2, factoring the squares over 3.
Factoring the difference of squares. Week 2, day 2. The difference of squares, number 3. Factoring okay. On 3. Okay. So we have 121 y squared minus 36. And if we're just factoring, I don't know why they have it set equal to 0, because if you're just factoring, you don't... Man, we're going to get people called on us for dog abuse. What did you do?
I was scared of them.
Come here, you want to do some math? You want to explain the difference of squares? Come on. Come here. Nope, he don't want to come. All right, so here's the key. Y'all just see the camera move? That's my dog. Let's do this again. All right. So the difference of squares, you got to get this one memorized. This is one of the fastest and most common used special factor. It says a squared minus b squared is a plus b and a minus b, and that's what it says on the sheet. But what you need to understand is a is not just x. A is this entire first term. So I need to rewrite this first term as something squared. In this case, I see 121 because I know my perfect squares is 11 squared. So I can really rewrite this as 11 squared y squared minus, and 36 is actually 6 squared. Now, these two squares, I can actually group it with parentheses and rewrite it as 11y squared minus 6 squared. At this point, you should be able to see what your a and your b is, because the minus is the minus, so we don't have to worry about that. The difference, the name of the thing, difference of squares, it's already taken care of with the difference. This thing inside the parentheses is my a, and this 6 is my b, and I just plug it in. So I have a plus b and a minus b, so I have 11y plus 6 and 11y minus 6, and I'm done. But you've got to get it memorized, and the key with this is you have to be able to find your a and your b. A lot of people want to just say, oh, 121, and you can always look to take a GCF out, but as soon as I saw this problem, I knew where to go to solve it. So not terribly bad, but you got to get that difference of squares down. And let me fix my camera. Oh yeah, in calculus, they show you that different, those limits to infinity. Crazy hard way.
Because I was like looking at the.
Oh yeah, I know. No, I totally know. All right, quit bumping my tripod, Coda. That's second time today. Although he's looking pretty cute right there on the camera. All right. What else, guys? What else? Huh? I think nobody cares is planning to knock out all of his math work today, because he's with me on the first stream and now he's here and he's just diligently working, doing what you're supposed to be doing. Good for you. Parents should be proud, and to really get bonus points with your parents, just randomly clean something at the house. Oh, it's a her. I guess everyone was like, it's a her. Yeah, we don't know by your screen name, so honestly don't care. Like you said, nobody cares.
James.
What?
Anyway, for f of x. It should be fun. Not that long.
Okay.
Right here is 8 plus x.
8 plus x?
Yeah, sorry.
Come on, learn to read math.
I know, my bad.
8 plus x
minus 4x squared.
Minus 4x squared.
Denominator. Square root of.
Square root of.
Plus.
6 plus x squared. Plus 7x to the 4th. The limit as x approaches negative infinity of f of x.
Write down the.
Okay. Easy peasy. Keep an eye on the chat in case they ask a question. All right, guys. Anytime you have questions, just fire. Until then, I'm just going to work on this. So I've got negative 4x squared plus x plus 8 equals the square root of 7x to the 4th plus x squared plus 6. 8 seems negative 32. That should be 2, 3, 4, and 5, or an 8. No. 6, 7, 8. So that top doesn't factor. 47 and 6 is 42. This does factor. So I've got 42. That's going to give me 7 and 6. Does not factor. Huh. Well, this kind of sucks. Whatever.
thought they found.
I'm getting there. I'm getting there.
Okay.
Because it's just end behavior. If I can figure the end behavior out, then I'm good. They're going to factor an x squared and an x squared here and create fractions. This is very similar to the problem. You remember the problem your daughter sent me? This is very, very similar to it. Because you end up taking the square root of x, and then when we do that, the square root of x squared is going to be the absolute value, and the negative will have to be a negative because your x value is negative. So I know how to solve this problem. I'm just trying to decide which way I want to tackle it. You didn't? That's a poor man's absolute value. It's actually one of the most missed questions. I really don't feel like doing this because this is going to take a little bit. But yeah, you'll end up, what you end up doing, if memory serves me right, we're going to divide by the highest exponent here. So then you would get 7. So we're going to divide by x squared. It'll be square root of x to the 4th. And I'll divide by the square root of x to the 4th, which is x squared. Is that how we solved it? Yeah. So I know how to solve it. I just don't feel like doing it.
Okay.
Seriously. Because, yeah, I just don't feel like doing it.
You went away for a second, then you came back.
But on that type of problem, and I didn't realize this until your daughter sent me that problem from LSU, is I had to have missed a bunch of those problems in calculus because it was never shown to me that if you do the square root of x to the 2k, right? 2k is an even number. You need to do the absolute value of x to the kth power.
Oh, okay.
So you have to do that, and then the actual definition of the absolute value of x is a piecewise, that you're going to do x if x is greater than 0 and negative x if x is less than 0. So then now that's why when you get that limit, x approaches negative infinity, you have to use this version of it, and that's why it would give you a negative number for an answer.
Oh, okay.
Guys, anybody have questions, or I'm going to shut this stream down because I've got some adulting to do. And my dog's being annoying. I have to go discipline him. Oh, yeah. Yeah, I don't think anybody's got any questions. I'm going to give them till, what, 44? It gives me 5 minutes. If not, I'm going to shut the stream down. I wonder if I can remember the chain rule. Can you look up a... No, I'll look it up. Chain rule derivative. Because I struggled with the chain rule too when I learned it. I just need a problem. I know what it states. I'm not doing a trig function 1. 5z minus 8? The square root of 5z minus 8? Sure. So f of z equals the square root of 5z minus 8. To find the derivative, watch how easy this is after I learn u substitution. I'm going to say u equals 5z minus 8, right? I'm going to take the derivative of that. So my du is just simply 5, right? So I'm going to rewrite this in terms of u, and I want to say f of u equals the square root of u. Now, to take the derivative of u is I'm going to do u to the 1/2 power. I want to pull it down, and I want to have 1/2 u to the negative 1/2 du, right? Now, plug everything back in. I have 1/2 of 5z, this is dz, 5z minus 8 to the negative 1/2, and my du is 5 dz. And now I just clean it up, and I'm going to get 5 over 2, the square root of 5z minus 8 dz. Now, this is basically the chain rule, but this is the actual process of it, because they tell you to take the derivative of the inside, put it on the app, blah, blah, blah. They give you a set of rules, but if you learn this process, you never have to try to memorize the chain rule formula. This is all math lab stuff.
Yeah, exactly how. Our rule.
Right, yeah, you would.
One right above it.
You would move, yeah, you would, but you wouldn't have this. You would just have this.
Right. Why are we going to write the function of the composition? Week 2, day 3, number 4.
Week 2, day 3, number 4. Still, week 2, day 3, number 4. Well, there's only one number 4 on here. We are multiplying. Okay. So we have x squared plus 11x plus 2 times x minus 5. All right, so this is distribution property. We can call it FOIL, first, outer, inner, last, an acronym let you remember, or you can do the box method. I'm actually going to do the box method, but I'm actually going to put a placeholder here for my x squared, so I can actually make it a box and not a rectangle. So what I'm going to do when I have my kids actually do this is I actually have them put in a 0, a placeholder. So I'm going to rewrite this as x squared plus 11x plus 2 times, well, I don't want to change this equation. The only thing I can introduce to this equation is I can multiply by the number 1, or I can add 0. So I'm going to add 0. And I want to do 0 x squared plus x minus 5. If you look at this equation, they're exactly the same. I just added a 0 in there. Now I can set up a box so all my information can be arranged nicely. So I'm going to do x squared on top, then an 11x, and then a 2. And down here I'm going to do a 0x squared, an x, and my negative 5. And I'm going to make a nice little box here. Because if I don't put this placeholder in, I'll actually get a rectangle and things won't line up pretty. And you'll see what I'm talking about here in a second. So I'm going to do x squared times 0x squared is 0x to the 4th. Then I'm going to do x squared times x. This is x cubed. And I'm going to do x squared times negative 5. And this is negative 5x squared. And I'm going to do 11x times 0x squared. And that's 0x cubed. 11x times x gives me 11x squared. And 11x times negative 5 is negative 55x. Now I'm going to do 2 times 0x squared gives me 0x squared. I do 2 times x, which gives me 2x. I do 2 times negative 5, which gives me negative 10. Now, I'm going to change colors here real quick so you can see why I actually had you do the placeholder. If you look on my diagonals, everything lines up with the same exponent. If you don't do that placeholder, it won't happen this way. This is a nice, easy way for you to be able to see everything. So all I have to do is look at the diagonals and add them. Well, I have a 0x to the 4th. I don't need to write that. That's fine. But now I have x cubed plus 0x cubed, so I have x cubed. Now I have a negative 5x squared, 11x squared, and a 0. Well, this just, when I add all these, that gives me plus 6x squared. Here I have a negative 55x plus 2x, gives me a negative 53x. And then I have just a minus 10, and I'm done. The key to this, to make your life easier, is really to put a placeholder in there. You don't have to. You don't have to put the placeholder in there, but then when you do a box like this, things aren't going to perfectly line up. And if you can get things lined up, in my experience, the students have less mistakes if you can get it lined everything up in the diagonal. What?
Never seen the box method.
I hadn't either until I started teaching high school.
I always just multiply out.
I would have multiplied. I personally would have just multiplied that out because it's fine. Right. However, but since I know the box method, if I had to do 4 and 4, it organizes the data very well.
Interesting. That would have made it like, because like you said, it was super organized.
Foil's kind of dying, to be honest with you.
Yeah, more. I was like,
yeah, I mean, my students, and I do foil all the time in class, but a lot of them prefer the box, but then they get frustrated because, yeah, sure. Trying to get me to do all of them. Seems like they're just trying to get me to do all of them. So I'm going to help you set this up, but I'm not going to finish it. Are you sure? I'm pretty sure you're trying to get me to do all of them so you can just copy my work and turn it in and say it's your own. I'm not going to take this. I'm not going to work this entire problem, but I want to show you what they're doing to this problem, because earlier I always said make sure you try to simplify to make your next step simpler, and that's actually what's going on in this problem. You have x squared plus 3x plus 7. What'd they say? Oh,
Oh, no, I'm not like that.
Plus 7, and then 2x minus 3x plus 4. Okay, so that's how it's written right now. And before I'm going to do anything to multiply, I want to make my life simpler. So I'm always looking to simplify. And when I glance here, it's already as simple as it can be. I don't have any like terms that aren't combined. There's no fractions that can be simplified or anything like that. But when I look at this one, I have a 2x and a negative 3x. I'm like, what's that? What's going on there? Just put them together. Make my life easier. So I do that, and I want to get x squared plus 3x plus 7 times, well, 2x minus 3x gives me a negative x plus 4. This looks an awful lot like the problem we just solved, because then all you have to do is put your placeholder in there, do a 0x squared minus x plus 4, and finish it out just like I did that last problem. Combine like terms. Look to simplify to make your life simpler. That's the only reason why we simplify in math. Not to make your life as a student tough, is to make your next step of math simpler. I could have distributed all of this, right, and not simplify it. But it's by simplifying it, it goes down to a very simple, a much simpler problem, which is less likely to make a mistake. So I'll let you finish it from there.
So set up your box.
Uh-huh.
We start with your.
Yeah, I always go
across to the right, and then.
Mm-hmm. Yep. So I'll let you finish that. I'm not going to work it all the way out.
And then so your answer is the stuff that's on the, so you add
the diagonals, yeah. And if I was on a regular dry erase board, I take my finger and I swipe it out, because where they intersect, it turns into a plus sign. So if you just swipe it out, you can see pluses on the diagonal.
Huh.
So things I've learned from teaching.
That's what your daughter was talking about, box method.
Mm-hmm. Yeah. I'll be honest with you. I mean, foil's great, and that's the way we were learned, and we were killed and drilled on foil. But for a lot of kids that are visual, the box is much better.
Yeah, for sure.
But for me as a math person, it hurts my soul to see the box method. I would rather just do the distribution property, be done with it. But It's about them trying to get it right.
I mean, the box method.
It organizes it better.
Right.
And I've done that so much.
Yeah.
Like when I'm multiplying, I remember one of my professors had us do a 7-term polynomial times a 4-term polynomial, which then we ended up with 28 individual terms.
Mm-hmm.
And if you don't know you have 28 terms, you have to count each and every one of them to make sure they're all accounted for. And then you have to start combining like terms, and you're searching over 2 lines, which becomes a pain. The box would have been much easier if I knew that when I did that problem and put those placeholders in, because I just set up a box and just I have zeros in there, but 0 times anything is 0. It doesn't matter. And 0 plus anything is 0. So what else? Any more questions? Nobody care? You got any more question for me? I think it's just been us. It's like one-on-one tutoring time. Yep. All this is about, just to help somebody. You need some energy. Yeah. All right. Well, there's 9 minutes for an hour. I'm going to call the stream. I'm only going to do one stream for the rest of the week, starting at 5 o'clock, and I'll do it for like an hour and a half, maybe 2 hours, depending on how many questions. Maybe a little less if nobody's on there, because I'm just going to sit here and just whatever. So yeah, hopefully tomorrow there's more people on there than just a couple of us.
Maybe it's asking you.
Not a problem.
Like, as if they have problems with.
Oh yeah. Yeah. All right, I'm killing the stream.